Hello dear students, we are in the module number 5 and in this session we are going to discuss about the conductometric estimation. So under module number 5 we have started with the instrumental methods of analysis and completed the potentiometric estimation of redox iterations. Okay, so in this session let us discuss about the conductometric estimation. Okay, theory, instrumentation and applications of the conductometric experiment. Okay, what is the principle here? Here in the principle of the conductometric experiments are, these conductometric measurements are generally acid based titrations. Okay, and we will be measuring the specific conductance of this acid base experiments. We are measuring the specific conductance of the solutions given. Okay, and that conductance will be depending on the number of the ions and the mobility of the ions present. Okay, conductance mainly depends on the mobility of the ions and also the concentration of the ions in the solution. Okay, and this depends on the Ohm's law. And what does the Ohm's law says? The current I flowing through the conductor is directly proportional to the voltage and inversely proportional to the resistance, which is given as I is equal to V by R. Okay, R is a resistance. Reciprocal of the resistance is conductance. Generally telling, the material which allows a heat and electricity to flow through it easily is called as a conductor, and the process is called as conductance. Okay, there are three types of conductance: specific conductance, equivalent conductance and molar conductance. In our present conductometric experiment, we are measuring the specific conductance of the solution. What is this specific conductance? It is the conductance of the solution which is kept in between two platinum electrodes of 1 centimeter distance, which are kept at 1 centimeter square area apart. Okay, so we are measuring at that area the conductance of that particular solution. Okay, which is called as a specific conductance. Okay, this is about the theory of the conductometric experiment. Coming to the instrumentation, the conductometric instrument, which consists of a digital conductivity meter, will be there. And here we are using the conductivity cell. The conductivity cell is made up of two platinum electrodes, which is made by two platinum electrodes. Okay, that we are using, that will be dipped in the analyte solution. Okay, and will be connected to the conductivity meter to measure the conductance. Okay, and then here we will be adding the titrant from the burette, and after the each addition we are mixing it well, stirring well, and after we will be measuring the conductance after each addition of the standard solution added. Fine. So coming to the application part, application of conductometric experiment. First application is the reaction between the strong acid and strong base. Okay, we are given a strong acid and we need to find out the amount of the acid present in the given solution. Okay, conductivity will be giving a 100% accurate results. Okay, because we are taking all the values graphically, so it will be 100% accurate. Okay, what happens here when we take a strong HCl and when we titrate against the strong base against NaOH, like NaOH, what will happen here? See the reaction. Okay, when we add NaOH to the concentrated strong acid like HCl, okay, HCl, what will happen? There will be a replacement of highly mobile H plus ions with the least mobile sodium ions. Okay, there is a replacement of highly mobile H plus ions with least mobile sodium ions. So the conductance decreases first in the experiment. Why the conductance decreases? Because of the replacement of highly mobile H plus ions with least mobile sodium ions. Until the HCl is present, conductance will be decreasing. Once the HCl is completely neutralized, what will happen? There will be an increase in conductance, that is due to the availability of the hydroxyl ions, okay, which is from sodium hydroxide added. Okay, so when we plot the graph for this taken values, we will be getting a graph like this. See, the conductance decreases first, okay, and then after once all the strong acid is neutralized, it will be increasing. Okay, the point of intersection of these two lines will be giving us the neutralization point. Okay, by using the neutralization point, we can calculate the amount of HCl present in the given solution by using this calculations. Okay, first we should find out the normality of the HCl. Once we know the normality of HCl, multiply the normality with its equivalent weight, that is 36.5. We will be getting the amount of HCl present in the given solution per liter. The second application of the conductometric experiment is when we are given a mixture of acids, okay, and we are titrating with a strong base, what will happen? Generally, if two acids are mixed and it is given, it will be difficult to find out the amount of acids present in the given solution by using any other methods. It will be very difficult. It is not at all possible because two acids are mixed, okay. That we can find out by using the conductometric estimation. Okay, so what happens here? In our beaker, we have a mixture of acids, that is strong acid HCl and weak acid acetic acid, okay, that we are titrating against NaOH. Let us see what will happen here. Okay, when we are having a mixture of acids and it is titrated with a strong base like NaOH, first the strong acid starts neutralizing. Okay, strong acid starts neutralizing. Okay, like previous case we have discussed, what happens here? There is a replacement of highly mobile H plus ions with the least mobile sodium ions, so the conductance decreases first. Until the HCl is present, the conductance will be decreasing. Okay, once all the HCl is completely neutralized, what will happen? It will start neutralizing the weak acid. Okay, when the strong acid is getting neutralized, you will be getting a reduction in conductance. And here what happens? When the weak acid is getting neutralized, there will be a formation of sodium acetate and the conductance of this is less. Okay, so we will be getting slow increase of conductance. Okay, so there will be a slow increase in conductance when there is neutralization of the weak acid. Okay, after once all the weak acid is also neutralized, what will happen? Because of the availability of the hydroxyl ions, once again the conductance will be increasing. Okay, decrease in conductance, slow increase in conductance and steep increase in conductance. When we plot a graph, we will be getting a graph like this. Okay, by knowing the V1 and V2, what is this V1? V1 is the volume of the base required to neutralize only the strong acid, and V2 is the volume of the base required to neutralize both the strong and weak acids, and V2 minus V1 is the volume of the base required to neutralize only the weak acid. Okay, by using the same formula, we can calculate the amount of the HCl and the weak acid CH3COOH present in the given solution per liter. Okay, by any other methods, if mixture of acids is given, it will be very difficult to find out. That can be determined by using conductometric experiments. Okay, the third applications of the conductometric analysis is if only weak acid is given and we are titrating against the strong base, what will happen is the conductance will be slowly increasing and there will be a steep increase in the conductance. The point of intersection of these two lines will be giving the neutralization point, and we can find out the amount of the weak acid present in the given solution per liter. As we do know, the conductance of the sodium acetate is less, we will be getting a slow increase in conductance values. So when you plot the graph, you will be getting a graph like this. The point of neutralization of these two lanes will be giving the amount of the base required to neutralize the weak acid, and by using the same type calculation, we can find out the amount of the HCl present in the given solution per liter. Fine. So these conductometric experiments are more applicable. Okay, they are having more applications. Mixture of acids can be titrated accurately, which is not possible by doing in any other methods. Okay, and for some experiments now where potentiometric methods fails to give the results, even that can be done accurately by using conductometric experiments. Okay, and even it is applicable for any colored solutions, turbid solutions, or solutions of any normality. Okay, solutions of any normality, okay, can be accurately estimated. These are about the advantages of the conductometric estimations. Okay, we can do for any type of solutions, turbid, colored, colorless solution, or any normality solution. We will be getting the accurate results, 100% accurate results. Okay, fine, and we will be meeting with the next session with a new topic. Until then, thank you.